I put A, B, and C in their appropriate places. And then I hope it all works out. Keep an eye on my work. I've been pretty off the wall today. 16. There's a minus and there's a negative. You got to look for that when you're doing quadratic formula like nobody's business. You see that minus in the formula and the negative 8? Totally makes it positive. So 32 over 2. You rolling with me? Negative 4 plus or minus. And I got 48-ish. How about exactly? Okay. All right. I got some room left. I'm not done. You thought quadratic formula was a mind, kind of getting your mind back in gear. What about simplifying radicals? How about that for fun? Do you remember how that goes? Are there any perfect squares that go into 48 by any chance? Oh yeah, 16 goes in 2, 3, oui, muy bien. I'm very multilingual today. Do you like that? They all work. Let's do 16 times 3 in there. I can make this bigger, bigger, bigger. 16 times 3 all over 2. Now I'm not going to leave it like that. So it's negative 4 plus or minus the square root. I forgot something. I'm going to take the square root of the perfect square. That's why we did this in the first place. The square root of 16 is 4. I cannot take the square root of 3. And then I take it all over 2. I'm still not done. There's one more step. So negative 4. So when you have a simplifying a radical, remember you take the perfect square. You can take the square root of that, leave the other number under the radical. Square root of 16 is 4. It's out front of the radical. Now in plus or minus, these are two terms. Anything separated by a plus or minus is a separate term. And you may divide those separately. So I'm going to divide the negative 4 and I'm going to divide the positive 4 here, both by the denominator 2. So these guys are going to become negative 2 plus or minus 2 radical 3 respectively. That, ladies and gentlemen, is a wrap on that one. I only have 13 of those for homework. Might be 1 if you're lucky. I don't even know if I threw it in there. But yeah, that simplifying is not usually a favorite topic, but it happens sometimes. There is a no calculator section, usually in each of our tests. So back to work. So back to 4. Oh, let's go 6A. If you need me to go back there, let me know. And again, I'm recording this thing. It's getting lengthy, but it's going to be good. Okay. This. How do we solve these algebraically? I mentioned solving right before lunch. I said, kind of start with distribute or other items. And the or other items is I want you to know that sometimes it's best to square both sides to get rid of a radical. If you can isolate a radical on one side, you want to square it to get rid of it. So I'm going to square both sides, and that's the key. Square both sides. That's so mathematical. I love when I write things like that. So I get 2x minus 1 squared. And when you square a square root, it's gone. Just like that. Now, interestingly enough, technically though, what I'm going to write here in purple or in green, there is when you square both sides or square the square root kind of thing, there's usually this plus or minus that kind of happens, but we'll talk about that more in the future, a little more number theory things, but we're good right now. Just leave it as squaring gets rid of a square root. Then I want to maybe expand this a little bit, and that is foiling or distributing. I'm going to do it mentally. So effectively, I'm taking 2x minus 1, and I hope I remind myself to sit down and show you guys that if you've never done it. I'm going to FOIL this out, and mentally, I'm just going to take the first two terms, make 4x squared, and then I know that I'm going to have 2x times negative 1 twice, so I get negative 4x, and then negative 1 times negative 1 is positive 1. So I usually go about it that way. Get everything on one solving, and it's got quadratic happening. Get it equal to 0 as your mantra. So you go 4x squared. Take away an x from both sides. You get minus 5x. Plus 1. I'm going to add 1 to both sides. So it's plus 2 now. And I think that's what I got before. Yeah, that looks good. That little beauty doesn't factor. I'll just tell you that right now because we needed a quadratic formula, something like that with a special result. So let's do x equals the opposite of b, which would be positive 5 plus or minus the square root of b squared, which is 25 minus 4 times a and c. I can't do that mentally. All over 2 times 4. Good. Finish this out with a 5 plus or minus the square root. Oh dear. 4 times 4, 16 times 2 is 32. 25 minus 32 is negative 7 over 8. There's something happening. Y'all know what that means? Oh, es posible. But it's unreal. You know what I'm saying? It's unreal. Impossible works for that too. For today, it's impossible, but it's unreal, not real. Non-real solution. So the radical over a negative number is an imaginary land. You're right. We play with imaginaries later a lot, and they're really cool in their own right. Especially for you future programmers. Gotta know imaginaries. Okay, so that's one option. Next, there's supposed to be an equal sign. Sorry about that typo. Same thing, square both sides, but different result. I'm going to whip through this a little bit quicker because I'm doing exactly the same thing. I bet you could beat me. So you got radical gone because I squared both sides. Then I FOIL it out, so I got x squared plus 4x plus 4 equals x plus 14. And you combine like terms or get one side full of this stuff, set it equal to 0. I think I get this. Minus 10 equals 0. I think. Okay. And then you try and factor it if you can. Are there factors of negative 10 that work? Add to 3. Negative 5 and a positive 2 would be negative 3. So it'll be a positive 5, negative 2. Think? 5 and a negative 2. Let's do it. So we get x plus 5. These are the factors, not the roots. That looks good. And then the roots then are the opposite of those factors. So our solutions are where this is equal to 0. Remember, that's what we were solving for. I might highlight that instead. That's better. Okay. That's x equals negatory 5, and x equals 2. I like that one. It's clean. Okay. What do we got for? Do you have a C? No C? No C. Oh, we're so close. We are so good. All right, things to know real fast. Some notation about this stuff. The idea of these solutions that we just came up with, let me give some synonyms for solution that we got. So solution to f of x basically equal to 0 that we just got done doing multiple times. Well, sometimes we just call it the solution. Okay, so we want to leave that one in there. Yeah, something like that. And sometimes we want to call it the root. I think I didn't even give room for all these. So sometimes it's a 0. Sometimes we call it a root. I'm going to put a fourth one in there. Sorry, that didn't make the notes. I would call it the x-intercept as well. Oh, bother. There we are. That's what they say in Mary Poppins. Or that's what Mary Poppins says. Oh, bother. Isn't that what she says? Okay. That's going to be at the Des Moines Playhouse. Did you know that? Mary Poppins? Man, I'm tempted. Boy, that would be fun. Okay, next one. Hidden behavior. Again, this is hidden behavior. Naughty and nice. Get your calculator. Let's see what's hidden. Let's go find out. Actually, I think some of these graphs really are being naughty. That's why we're going to show them. We're going to tame these. Grab that thing. Are you ready? Go to y equals, so I gotta get out of full screen here. Sons, get out of there. Get my calculator up. Okay, under y equals, you wanna put in these two equations. I'm gonna turn them on. There's a couple things you need to know before you graph. Make sure they're on. Anything else you don't want to graph, turn it off by hitting enter on its equal sign. That plot 1 at the top, you don't want that. You want that off. So you hit enter on plot 1. And only the things that have a darkened equal sign will be graphed. Oh, by the way, this is numbers 7 and 8. So I'm not just, you can read mine, but I think it's cut off. You want to look at your sheet for 7 and 8. But they go into y equals. And once we graph these, I'm gonna turn off one of them, just do one at a time. Let's do 7 there first. Yeah.
1 divided by x squared minus 1.
Yes, and I didn't, you know what? I put it all to the 0.5, which is the same thing as taking a square root. And I'll tell you why I did that. I forgot the square root when I first did it. So I had to go afterward and hit 0.5 power. But you know what I could do? Since we got some time, I'm going to put in the square root. So you guys remember you can do second insert right above delete. We put a little radical in this, which is second x squared. Whoa. That's not going to be fun. All right, I'll just start over. X squared minus. I was doing just fine until you suggested I start over. Goodness. Oh, stop it. Stop it. It's really stubborn. Well, this is complicated. You guys got there? Okay, you want to give a good graph of it. I'll catch up in about 10 minutes when I figure out how to delete this operating system is awesome and not sometimes. Oh my word. Really? I thought it all deleted. Yep, you want to go away. Can I just be done? Can I just get out of that? Just go. That's going to work, right? Okay, it says in your directions, it says do z decimal. So z means zoom. Zoom is the graphing hub. So I'm going to graph my y equals 1, y1. You can see it in the middle screen there. Then go down to decimal, which I believe is 4. Yep, there it is. So I'm going to just type 4. It's the 4th option. Yeah, I know. It's my typing. If I could just get rid of that. Let's try it again. Zoom, decimal number 4. Hey, that looks good. Okay, so there you go. It looks like that graph, how many roots does it seem to have? You'd say, I kind of don't see any. So you guys see what I'm seeing? It's not happening? So what we would do, though, is mathematically we'll prove that just so happens there are roots in this function. That graph is totally misleading. Calculators can be the biggest, fattest liars you'd ever run into. So here's how we're going to solve this. Watch carefully. 3 minus 1 over radical x squared minus 1, which seems to have no roots. Let's prove it. If you set it equal to 0, that means we're looking for when it has a height of 0. Effectively, this means when do roots occur, or zeros, or solutions, or x-intercepts, all those synonyms that we learned today. That's what I'm doing by setting equal to 0. This one I'm going to do some wonderful algebra. I am going to take this whole negative 1 over radical thing and add it to the other side. So what we end up with is 3 equal to that whole thing. So x squared minus 1. Okay. Then I want to pull a cool trick for you guys with fractions. You don't want to deal with them. None of us do with solving. Multiplying by the denominator. That's your big friend, big trick. Anything can be resolved fractionally wise.